Hello everyone, welcome back, and in this lecture we are going to create our network scanning application. So in our previous sessions we have mastered pure bash watchdog, proving we can detect a single open port using the dev TCP pseudo file. Now we are taking that concept to the next level, which we will be creating our own full-scale network reconnaissance tool. Now we face here a critical constraint here. So no external binaries allowed here. Like we will not use Nmap, no ping, and even no sleep here. So scanning an entire network usually requires these specialized tools, but today we are going to force the Linux kernel to reveal its secrets. Now the core challenge here is speed. A sequential scan is too slow. Our solution is the aggressive pure bash LAN scanner. So we'll be combining parallel processing using the bash's built-in drop control, this ampersand, and wait will be used here with, of course, targeted network traffic generation. So we are not waiting for individual connections. We are launching dozens simultaneously to aggressively flood the ARP address resolution protocol cache. By the end of this lecture, you will understand how to use Bash's internal functions to create a high-speed, zero-dependency host discovery tool. Now let me check the my voice is recording, and then we can start right on. Of course, we also need to arrange the display. Okay, here we are. So you can watch it in full HD. And it will just take a second here. Here we are. Yeah. Now let's get started our coding here. So we will be using user bin in environment bash. Now this is called the shebang line. Now it tells the operating system which interpreter should run this script. Now this user bin environment bash here finds the location of the bash interpreter using this environment command. Now this is preferred over using bin bash directly, because on some systems bash might not be loaded at the bin bash, which makes the script more portable, this piece of code here. And here you can see I have created new theme for this here, since most of you asked that you need to change the theme, and that is the theme. And this is going to be the pure bash based LAN scanner that uses address resolution protocol to detect devices on the local network. Now it doesn't depend on the tools like Nmap or ping, like only built-ins like the dev TCP, or which is the pseudo file of a system, the pros and net ARP. And the script here scans IP addresses concurrently and reports found devices. Now it's written also not to crash silently if something goes wrong. Now we will firstly define our default variables fastly. First we will define the default subnet, which is the first 3 octets of an IP address. So subnet, actually make that here. Yeah, subnet scan port here, or yeah, subnet should be the subnet, right? Subnet here 192.168.152. This is going to be our default subnet, which is the first 3 octets of an IP address. Basically, this here means that if the subnet is already set, not empty, then keep it. Otherwise, assign the value after the colon. So you can also can add the subnet from the options page without editing this and opening and editing this shell command, right? And yeah, we will also create our default variable named scan port. It's again gonna be the scan port for default, and if it's not given any value, so here we are giving the default TCP port to attempt connections. The 22 port 22 here basically means SSH, and here we will also assign the max IP. Again, we will use the same. Max IP is going to be 254. Now this is going to be our maximum host number in the subnet to scan. So it's going to be scanning from all the way from 1 to 254. And yes, let's actually do the maximum drops variable as well. If not, if given, use the maximum drops drops here. If not value provided by the user, then we will be using let's say, yeah, 120. Now this is basically the maximum number of current connection attempts, and we will also add the pool interval. Again, we will use the same style here. If not, we will use the pool interval variable if we got any from the user, but if not, we will be using all the way 0.4. So this is basically the delay in seconds between checking address resolution protocol results. Here, let me check my voice. Yes, it's recording perfectly fine. And yes, after that we will also have verbose mode. So this is basically asking the whether or not to print extra logs, right? And this will be useful in most cases. And first we will create our helper function, which is the usage. Now this function prints help text and usage instructions and then exits. So usage here will be cat eof here. So the usage is going to be options, like most other. Here the S for subnet. So subnet is going to be what? A subnet, B subnet, or C subnet. So basically it's giving the first 3 octets. The default is subnet if not anything given. You can see here default is 192.168.1.5.2, and we will also go add the port here. Now this is the port to connect to. The default is, you can see here, 22, which is the SSH. Default is scan port. After that, we will also give the max IP. It's gonna be all the way from 1 to 254. Now we also have the default. Let's actually add. Now you can see we have a max IP 254 as well. So this is the highest host octets to scan. The default is here again is the max IP, right? G here and the jobs N, and this is the max concurrent jobs. Max jobs here. Now you can see the max job if not given the value from the user. We will set it to the default 120. And one last thing we have here is the verbose mode here. Basically, this is a verbose mode. The default is false. H here, help. In the help, we will basically show this, right? The example, let's also give the user an example how the user can run this. So 0, this is gonna be script name 192.168, for example 1, P here 22, the job here 150, and verbose mode. And after that we will end this and exit. Exit 1. So we will exit with the status code 1 after showing the usage info. And now we're gonna need to create our while loops. So here, while, of course, we need to actually do outside this usage command, the while loops, or yeah, we need to do outside this usage command. And here we will have the hashtag here do. Now this means basically the number of remaining command line arguments. While it is greater than 0, then we will just keep looping here. So okay, here we fix this. Yeah, and here while we will also use the case 1 in subnet. The hashtag if the argument is s or subnet, assign the next token to the subnet here. By the way, I will be sharing this piece of code to my blog website, theoxally.com. You can check it out from here and just get the idea. And yeah, that's basically what's going to be doing here. So if the argument is s or subnet, we will be assigning the next s token to the subnet here. So subnet equals and 2, and we will be using the shift 2. Here we are removing both the option and its argument from the list. And after that, we will be using the port. Port here. scan port. Then we are going to shift 2 here, and after that M. The M is for max IP, you know, max IP, and here max IP, shift 2, G for jobs. The max jobs is gonna be and then shift 2. In this case, the verbose will not be having any arguments. Just by using the V here, that will be meaning that user wants to enable the verbose mode. So that's basically the V has no argument. So we will be shifting by 1. And help will also not have any argument. And that's why we will be basically shifting by 1. Or yeah, let's help usage function. So when a user presses, gives the parameter as, for example, my bash.sh help or h or help like this, will be running this usage function. And after that, let's actually, yeah, we will just call the usage function and exit. And now the asterisk here matches anything else not covered above here. So we will be basically writing that unknown argument, the argument name, and usage. We'll write it again, and here we are. After that, ESAC, and done. Yep. And here, see this section 3. Yep. Our code doesn't have any errors. Let's give it right now. Let's give parameters, right? Help. Here, it shows the help menu. When we write, let's say, verbose, it quits. When we write S, it waits for the subnet mask. That's perfect. Now, thank you for watching, and in the next lecture, we will continue our code.